Then let's start. Good morning, everyone. Today we'll continue about spreadsheet function for commercial, for financial analysis. Okay, and then hopefully we can continue with data table and whole sheet if we have time. So you can go to Google Classroom and then download the financial function. Our slide on financial function. Are you ready? Yeah, so as a recap, last meeting, we discussed about compound interest, right? You make these two tables. You still remember? And then I introduced the concept of equivalent so that you can have the same amount of money, okay, when you convert based on certain interest at different time. So this kind of formula, so we derived formula last time. Okay, so this kind of formula represent the equivalent of money that you have at present, P, okay, and in the future. So the equal sign here is important because this represents the equivalent. Okay. And then K here is the interest rate and N is the time period in number of years. Okay. And of course, you can reverse the process. So if you know the future value, you can know the present. Okay. And then you can also calculate the interest. Okay. Last time, the last part of our lesson was to find the inflation rate. Okay. All right. So, okay, let's continue with today is about Rule 72. Have you ever heard? Rule 72.
No, not yet.
Okay, so at least now you hear about it. Okay, so Rule 72 is actually very well-known rule. State that the number of years required for the money to double at interest K is equal to 72 divided by that interest rate. For example, if your interest rate is 6%, okay, your money will be double at about 72 divided by 6, which is 12 years. Okay. So if you don't have calculator to compute, so you just remember Rule 72. Rule 72 will give you the approximate, not the actual value, but the approximate number of years. Okay. At which percent you can double your money. So what is the accurate time period is using this formula. I think I remember Pancha derived this formula last meeting, right? So, okay, so using this formula, can you practice? Suppose you have 1,000 today, and say you put in a cooperative that give you dividend 10% a year. The question is, how long should you wait for your money to reach double, 2,000? So you can use both Rule 72 and the actual value of the time period. Okay. You practice that. So formula is this one. So F is how much? F is 2000, P is 1000, K is 10%. So what is N? What is N? PV, can you calculate that? So if you open your Excel, so you have a present value is P, right? Future value F. You have interest A. Question is period. Now you know the three of them. You want to know K. So this one is, how much is the P? 1000. Okay. How much is the F? 2000. How much is the K? 10%. Okay. This is 10%. So what is N? So based on okay, period, approximate period. So approximate period is based on N72. Yeah, it is what 72 divided by 10%. So this one is 10%. So supposed to get 7.2 years. What is the actual value? Actual value based on this formula. Okay. So we take the loan, the F divided by the P, right? Divided by loan again, 1 plus P. Almost the same, right? You see that? So using row 72, you get 7.2. Okay. When you get the actual value, you get also 7.27. Okay. Almost the same. Do you have a question? Can you make it?
Yes, sir. Okay.
Okay, good. So next. Okay. So now if we have row 72 is almost the same, is it always the same or not? So can we investigate this? Okay. So can you calculate the error? Okay. From K equal 1% to 35%. So what will be the interest rate of the rule 72? Yeah, to have more than 0.5% absolute error. So you create the table, something like this. Okay. So this is the K. Okay. This is the exact value. And then this is the row 72. Row 72 value. And of course, this is the error. Yeah. Okay. Let's do this. The format of the fit. Okay. So K is we start with 1%, 0.01. Until 35. This one plus 0.01. Until 35. So this one I can put it into a percentage. Okay. So what is the rule 72 period? 72 divided by this one, yeah, multiplied by 100. Right. And what is the exact period? We use the equation from the slide. Yeah. So the exact period is long. Oh, it's double, right? Long 2.
Yeah, just two. Two. Yeah.
2, okay. So divided by what? Ln 1 plus K. Plus. Okay. Oh, so the error, of course, we take the absolute error, okay. This one minus this one. Okay. Divided by the exact. So, okay, so we get this is the percentage of error. And once we make it, they just copy. Yeah? So we just make a copy. And let's see. So let's see this. Formatted paper. And then let's do some conditional formatting. Yeah? Oh, what happened? Is this correct? Why my pattern is not the same as in the slide? Oh, it's the same. Okay.
Oh, is it the same, sir?
Yeah, I think so. Okay. It's not the same. My part 3.4. Maybe the way I calculate error. Is it?
Maybe it's the other way around
It's the same, right?
on the slide.
Oh, maybe I divided by the rule 72. Maybe I divided by C2. Oh, no.
They're all the same.
Should be E2, that is the correct one, right? Okay, I don't know why is it different. Anyway, but the pattern is the same. So let's make it 2-digit. Okay. Let's make it 2-digit. And this one, let's make it percentage of 2-digit. Okay. So we do have, so rule 72 will be correct, okay, when it is about, 6% to 10%, isn't it? Okay, so in here, but once below 5% or above 10%, okay, so the result of rule 72 is not that good, isn't it? Okay. So at least you know. Okay, so be careful when you use the rule 72. Okay.
Sir,
Yes, go.
for the rule 72, why my number is so big?
You want to share your screen?
Okay. This one is correct, right?
I think you need to put what is that? Parenthesis at the bottom.
Oh.
Yes. Yeah. Okay. Okay. Error is no. You need to put parenthesis. Oh yeah, maybe I make mistake in the error. Is it? No, that's correct. So you need to minus the absolute value.
Yeah, this one.
Yeah, okay, that's correct. Okay.
Yeah.
Okay. You can put percentage if you want. Okay. Okay. And you can start to do a conditional formatting to see the pattern.
Sorry, sir?
Conditional formatting.
Okay.
Select all in the error. Yes. And then go to conditional formatting. I think the data bar. You can select any. Okay. You can start to see the error is getting bigger above and below 8%. Yeah.
Okay.
The visual is important. Yeah, thank you. Okay, good. So let's continue. So what happened is if your interest rate is not 1 year, but actually per month or per day, right? Or quarterly. So in that case, what you need to do is you divide, okay? So for example, your interest rate is actually per month, okay? So then you divide by number of months, okay? So for example, 1% monthly, so you will say 1 plus 12% in here, okay, divided by 12. 12% here is the yearly, okay, divided by 12, and then you exponent of m. M is 12 because this is monthly, so 12 months. So this is sometimes you need to check what is the unit of the interest rate. Is it monthly or yearly? So then if it is monthly or daily, you need to use this formula. Next is annuity. Annuity is very useful for computing the loan, okay, or the retirement. Suppose you want to take a loan from the bank or from money lender for your project, okay, say to buy car or to buy house. So when you receive the loan now, okay, then you need to pay the principal of the loan, P, plus the interest for N years. Okay? So if you start from next year, then you need to pay annuity every year. So the question is, how much is the annuity payment per year? So this is the formula. Okay. Anyway, Excel already have this inside. Okay. Later we will see the table here. So if you want to get annuity, so Excel use minus PMT. Okay. So minus PMT of K is the interest, N is the period, and P is the present. Now, of course, you can also reverse. Okay, if you know the annuity and K and N, you want to get P, then you use minus PV. Okay, so for the future value, okay, Excel also use minus FV or minus PMT down here. Okay, so please distinguish the two formula here. Okay. Number one is the annuity is computed for the payment at the beginning of the year. Number two there with the note 2 there, that means the annuity is computed for the payment at the end of the year. Okay. So why we use negative? That's the question, right? So because Excel would automatically put negative value for loan. Okay. If you want to make it positive, then you need to put negative value there in the beginning of the formula. Okay, so do you want to practice this? So suppose you have two choices. Do you want to receive $600 today, or you will receive $100 per year for 7 years? Okay, let's assume a 5% interest rate. So what is the choice that has higher value? Disregard anything else. Okay? So will you receive the 600 today or receive 100 per year for 7 years? So that means A is 100, okay? K is 0.05, right? And then N is 7. Then you calculate. Whether they have the same result or not. So whichever higher, that is the decision, right? Which one you will use?
So we use payment at the end of the year for B. Receive 107 years
They,
per year. So is
so,
it at the end?
so the result is, what is your decision? There are two options, right? You receive today 600 or you receive 100 for 7 years. So your decision is,
I would say receive 600 today.
why?
Because if we convert it to present value, all of it, the 600 is still higher a bit.
Oh, yeah.
The 100 per year would be $578 in present
Correct.
value.
Correct. Diffie, can you get it?
Wait, sir. I'm still calculating.
You're still calculating. So, okay, if you receive the 600 today, the present value is 600. Okay? Now, if you receive 100 for 7 years, so if you multiply 100 times 7, it looks like 700, isn't it? But if you put it into the formula of the present value, given the A is 100 for 7 years, okay, the value is actually only 578. So in that case, you will be better off to receive 600 today. Okay. Of course, this kind of question disregard the inflation. If you include the inflation, then without computing, you will say, of course, 600 today is better, right? So some insurance company will ask you, okay, to pay every year certain amount of money, right? Say you join an insurance, so you need to pay every month or every year A amount of money. And then they promise you to give you back, okay, big amount of money, F. Okay, the formula is this one. Okay, so what happened? Let's say you want to do retirement, right? So starting this year, you want to set some money every year for your own retirement. Okay, so assume that the saving interest rate is 7.5, but the inflation rate, now you have inflation rate, 4.5%. Okay, and you think that you want to get at least $5 million retirement 30 years from now. So the question is, how much should you save each year for your retirement? Wow, this is nice, isn't it? So this is thinking about the future. Okay? One day you will retire. Okay? One day you will not work anymore. So at that point, say you have 30 years of working. Okay? And then you said, after 30 years, I will retire. But at that time, I need to have at least 5 million. $5 million US. So the question is, how much do you need to save each year? And you know, the saving interest rate is 7.5%, inflation rate is 4.5. So how do you do that? Okay. So the interest rate 7.5 minus 4.5. Okay, so you practically have only this is okay. So you have Okay, so you just put it into the formula, right? So you know F30 is $5 million. N is 30, K is 3%, so you put it inside the formula and you get A. A is per year, you need to save 102. Okay, so that is divided by 12 approximately. So about 8,500 per month for your retirement. Of course, if it is dollar, then this is also dollar, okay? Quite heavy, right? For 30 years, every month you need to save this much. So of course, the numbers, you can just change that to the numbers of your interest. So now you know how to compute the insurance, you know how to compute the retirement, right? You know how to compute the inflation, right? So good enough? Yeah, all is just using Excel, very easy. Right? So this table is the one that you can use. Okay, I don't memorize this, but you can just check again this table again and again when you need it. Okay. So is there any question? So I will give you an assignment later. This one. So you will make a spreadsheet, okay, to compute the retirement plan. So N1 is the 20 years period of saving. Monthly you pay say 5,000. Okay, and second possibility is to invest the saving in the stock and bond that yields 10% per year. Now, when you retire, you withdraw every month X amount, right? So every year you increase X just to cover the 5% inflation. Okay, and the investment on the stock will still yield the same return. But remember, after 20 years, okay, you start to use. Okay, so during the first 20 years, you just save at 10%. Okay, after 20 years, you start to draw X. Okay, you start to draw X. But remember, your money is when you start to draw, that means your money depleted. Your principal depleted. Okay? In the beginning, first 20 years, you accumulate, right? Now, after 20 years, you retire. That means you deplete your money. Okay? Say, not only that, you also need to cover the 5% inflation. Yeah? That means X increase by 5% every year. The money that you withdraw, that X in the first time, yeah, always increase after. So X is the time that you withdraw the first time after 20 years. Okay, so these are the things that you need to know. Okay, how much is the total saving before you retire? Okay. And then X is how much you can withdraw per month. And how many years will your retirement actually sustain? Meaning, after you put 20 years saving, and then you withdraw X, right? The question is how long that money will last. If you actually live very long time, okay, will you still survive or not with that money that you accumulated? And this is a very practical question, okay? Because if you make this, you will know how the developed countries, for example, in Europe or even in Singapore, using CPF system, for example, how they compute, right? You can also create an insurance company based on this computation, if you want. So try to make this practice as assignment. Okay, I give you the example of computation here. Okay. I hope this is doable. And you submit it after the midterm. Okay, on Monday after the midterm. So you have 2 weeks to finish this assignment. Is that okay? Yeah. And second assignment, oh, you have 2 assignments. Okay. The second assignment is comparing. Okay. If suppose you have $100,000. Okay. So if you put in the bank, you gain interest of 3%. Okay. No risk. Another possibility is to invest your money in the stock market or a venture business. But there is risk. Okay. You will gain 7% interest on average, but the probability is only 50%. Okay. And you get also 5% possibility, probability is 10%, 3% gain of interest with probability of 20%, 1% gain with probability 10%, and you have also possibility to lose your money, all your money, okay, with probability of 10%. More realistic, right? So now you base it on the 10 years of investment period. So the question is simple. Okay? When you invest your money in the venture business or you put in the bank, and why? Okay, so I don't have the answer for that in the slide, so you need to make it. So 2 assignment, okay? Okay. Is there any question, Livi, Pancha? No problem. Okay, let's continue with a little bit about project evaluation. Last time you make this, but I want to make sure that you know. Okay. So any investment, any project that you make, right, requires some cost. So the cost can be the capital, the first money that you put. There is also operation cost. Every time you need to pay, every month. For example, operation cost, what? You need to pay for the workers, right? You probably need to pay for the materials that you buy. Okay? You need to pay for the electricity, right? Water, right? And so on. Including the toilet, you need to pay, right? Correct. So, and also there is a repair and maintenance cost. Okay, every now and then, for example, every 2 years, you need to maintain. Do you know the difference between maintenance and repairment?
Maintenance, it's not broken. You just check it or something like that. But repairment means it's already broken and you have to fix it.
Correct, correct. So if you do maintenance, that means you will not repair, hopefully. Okay, that means even if it is not broken, if it is already not so efficient anymore, okay, then you start to replace because they are old already. But repair, you wait until it's broken. So broken means you have no operation at that time. Okay. So there is also a cost for administrative and taxes. So the government is always charging taxes okay, for their own. Of course, you get benefit. What is the benefit? Benefit, of course, from the income. Okay. There is also possibility from subsidy from the government. Okay. Or salvage value. What's the meaning of salvage value here? Have you ever heard salvage value? Bahasa Indonesia, nilai sisa. Okay. Meaning if you buy a machine, for example, or equipment, okay, and then after some years, you need to sell it, right? But when you sell that equipment or machine, that means you still have salvage value. Okay. You buy at say 1 million, so you sell still 100,000. So that 100,000 is the salvage value, right? And of course, there is also a benefit in terms of increase, okay? Increase of the property value. The meaning of property here can be anything, okay? So it can be the land price increase or probably intellectual property increase and so on. Okay? So you have costs, you have benefit, right? So how do you know that your project or your business is actually good or not? Okay. So then you need to have what is called economic indicator. Okay. The most useful evaluation economic indicator for investment or project is these values. Yeah? Usually we call this NPV. What is that? Net present value. Okay? So this is the total benefit minus the total cost. But to calculate the NPV, you need to put all the benefit into present time, year zero. Okay? The same thing with the total cost, okay? Because they have different year, different interest rate. So you need to put all of them equivalent in the year zero. Okay? The same thing with BCR, okay? Benefit cost ratio. Again, the total benefit and total cost must be put into year zero, present value. The only difference is only the computation, okay? Minus, and then the other one is divide. Of course, when it is minus, so what is the criteria that it is good? NPV was positive, right? So if the NPV is positive, means the total benefit is larger than total cost. Right. What is BCR? The criteria to say that this is good. 1. Right. If the total benefit is larger than the total cost, then the BCR must be larger than 1. If the total benefit is equal to total cost, the BCR is equal to 1. But another economic indicator that is better, okay, is actually IRR. Excel also have the function for IRR to compute IRR. Okay, so IRR is internal rate of return, so annual return. Okay, that will compute. Okay, will compute what? The interest rate of your project, the interest rate of your business, right? So if your interest rate, if the interest rate of your business is actually lower than if you put in the bank or in the money lender, right? Then you better not doing that project or doing that business. Say, if you put your money in the bank, risk-free, right? You get 5%. Or you buy bond, almost risk-free, again you get 5%, right? And then your business is only 4% in the IRR. You will not do the business, correct? You better put the money in the bank and you sleep, correct? Right? But if your business, for example, you get 30%, the money in the bank, if you loan, is only 10%, right? So that means your business value is higher than when you loan. Then you dare to loan, correct? Why? Because you still gain 20%, correct? Okay, so this is the way to compute. So, and doubling time, the rule 72, right? So, what is the number of years to double your investment? Okay, again, yeah, to compute all of this, you need to put everything in the present value first. Okay, and then you can use the indicator. Okay. So this is the formula. Okay, so the IRR, the definition, so you need to convert everything, okay, into the present value, and then you can calculate the IRR. Okay, so let's practice. Okay, I will do. I ask you to do two practices. So practice one. Suppose you have a potential cash flow per year selling your software. Okay, say let's calculate for 5 years because software lifetime is usually only 5 years. After 5 years, you need to make again, right? So year 0, 1, and 2, you pay 25,000. Okay. Oh, sorry. Year 0, 2, you pay 25,000. Year 1, you pay 12,500. And then year 2, you pay 9,000. That's the meaning of respectively here. Okay. Year 2 to 5, each year you pay 15,000. Oh, you earn 15,000. So meaning that you start to earn in the second year. So can you calculate your PCR, NPV, IRR? Okay. So at the bank interest rate of time deposit is 5% per annum. And then what you will do, you need to decide, okay, whether this is actually a good business or not. Okay. So the answer is here, but can you make it? Okay, once you finish, you share your screen. Yeah, each of you. And if you work in projects or business venture, This is something that you will do very often, isn't it? So you can start to compare, for example, various businesses. Different business have different cash. This is the cash flow. So say if you create a startup company, you also need to compute this, right? This one is feasible. If your investment project feasible, so this is called a feasibility study. Cool.
So yeah, I did this. So for the first year, it cost us 25,000, and then the next year 12,500, and then 9,000, and then we have income from year 2 to 5, 15,000 each year, interest rate of 5% annual. Then present value of cost, I do PV. Oh, hold on. Oh, forgot. This should be 5. Because I divided by, yes, okay, so 5 divided by 100, and then this one, this is the year, right?
Mhm.
And then we have the future value here. So this is the present value, and this is the present value of the income here. So we do the same thing, just move it to here. And then PV net, we just this one plus this one plus this one, because this is already minus, right? So I don't need to minus it again. And then yeah, I sum. This is just the sum, right? This is just the sum. IRR, I pick IRR and then select this. We get 10%. I think it's decimal, but yeah, it is actually
I think
9.7.
the first year is year 0. 25,000 is year 0.
Oh, year 0. Oh, yes. Wait. Oh, okay. Then 0.
Yes, and then 12,500 is year 1.
Then we have
one more.
Yes.
And then year 1 have no more 15,000. The income 15,000 is start from year
Year
0. Okay.
Yes.
Okay.
Ooh, hold on.
IRR is the whole thing until
Yes, the whole thing.
yeah, okay, good.
We have some. This is correct. Correct.
Yeah, the PCL 1.12. Yeah, okay.
Oh yeah, this is the sum.
Okay, very good.
Yes, okay, sorry.
Right, right.
So yes, so and NPV we just select this. Oh, sum, and then select this, because NPV is just normal sum, right?
NPV is yeah, it's the same. Yeah, it's the same.
Yeah, just normal sum.
Correct. It's just a normal sum. What is the decision?
Well, we need to compare it if you like. if we it depends, like we have 4.26% right here, right? It means when we invest to the project, our interest rate will be 4.26%. If we have other option that has higher interest rate than 4.26%, then we don't pick this. But if not, then yeah, it's feasible. It's clearly feasible that the BCR is more than one.
But your interest rate is already 5%.
Oh, the interest rate. Wait. Oh yeah. This is like inflation or?
No, that's the interest rate that you put from the bank, right?
Hmm.
So,
Yeah, then probably we should not.
yes, you should not. Okay. Because your IRR is actually less than the interest rate already. You should not.
Yes.
Okay. So important is to know the decision. Based on these numbers, you need to decide. That is very important lesson there. Okay, so can you also do the second example, the practice? That is
Okay, sir.
a little bit simpler. Okay, it's only 3 years. Livy, where are you? Oh, can you share your screen?
Wait, sir. I the IRR.
Sir,
Hmm.
for finding the n, like when we want to find the rule of 72, like we want to find the length of the investment, right, to double. Can we use n per? Because I have.
Yeah, you can use.
Yeah, but it doesn't actually work. Like, can I show you something? Like here. So this is I tried this. Not this is from the previous example, right?
Example.
I use PMT, and then this one. This is the interest rate. This is the future value, and then this is the length, the year 30, right? And then we get this. But if I convert it back with n per, use this, and we should get 30, right, sir? We should get 30 back. Make this one the same.
So let's see in the out function, what is the n per about? N per of Excel.
Yes. Yeah, I looked it up.
First
Like,
is the rate. First is the rate, right?
yeah, the rate is 0.03 divided by. Because if I don't divide it by 12, it doesn't actually work. It just show num. But if I divide it by 12, it shows something, but it's not correct, and it's minus.
K is supposed to be 0.03, and then PMT, right? PMT is the payment.
Payment every year. Yeah, this one, right? I know. And then I don't have present value.
Yeah.
Present value is just 0.
Yes, the FP is the one that 104, correct? And then the type is whether you use for beginning of the end, right?
But it doesn't work. It just show num. It should show 30, right?
It's supposed to.
Yeah. I put 1 here because for the anom I also put 1 the type. So it's the same. That doesn't work.
So
I also tried this one, like and using len, the normal one that you taught us.
yes.
And this is using the 72 divided by 7.
Uh-uh.
And using NPER, it also doesn't work.
It doesn't work also.
Yeah.
I'm not sure why not it doesn't work.
Yeah, I don't know.
So if you try the examples in the help file, will it work?
In the help file.
So you check the help file of NPER, and then
Oh, how do we get that?
You just go to Google.
Oh, okay. Oh, on Microsoft help file, yes.
Yes. So I think they asked for divide by 12. Always the NPER in the example is always,
Yeah, always divided by 12.
right.
Wait, I tried. Like this one, right?
Yeah, if you divide by 12, it works, but different values.
Whoa.
Working also.
Wait, let's just do it. PMT 0. Present value, this one. Future value, this one.
Yes.
Close. Doesn't work as well.
Doesn't work as well.
Does it need this one? No.
No. So I'm not sure. So you try using the maybe the number, the value must be negative.
Oh.
The present value, for example, must be negative.
Maybe. Oh, can we just do this?
The future value is positive.
Yeah. Wait, what should we change?
The present value must be negative, right?
Present. This
Enter.
one. Oh,
Yeah,
it works, but it's a lot more.
Yeah, it's strange.
Oh, maybe we should. Nope. Okay.
No. So if you divide by 12.
Oh yeah, this one divided by 12. Yeah, it's close. Okay, it's close.
Yeah, it's close, right?
Oh yeah, okay, I see. Yeah, maybe this one, the present. Oh wait,
I think the negative value then.
payment.
Present value in the payment.
Oh yeah, 30. Okay.
Oh, yeah. Okay, you got it, right?
Yeah. Oh, this one I don't divide it by 12. Okay. Oh wait, this should just
No need to
work.
divide.
Yeah. Oh yeah, it's the same
Oh,
as the len. Yeah. Okay.
Exactly the same.
Okay,
So the clue there is negative value of the present.
Present or payment. Okay.
Yeah, that's the problem there. In Excel, they assume something, then you need to know their assumption.
Yeah.
So maybe you want to share your screen.
Okay, sir. Sir, I forget what to put in the IRR.
Okay. You go to the top. Your net present. That one from above, until 9. J. So J4 to J9.
Oh.
Okay, and then you close it. You don't need to. Oh, you. Okay, you got it. Okay. So then you need to make decision. Okay. So using if your IRR is actually less than your bank rate, so that's not okay. Right. If your IRR is actually larger, then it is okay. Okay, so up to here, is there any question aside from that NPER, which I did not put here? Thank you, Mancha. Okay, so then this slide of financial function is finished. Let's go to the next topic then, which is data table, which is the continuation of this. Yeah? Can you go to Google Classroom and download data table?
Okay, sir.
Yeah. So Excel also have ability to create a table for you. Okay, and this is very useful. Okay. If you want to check the value, okay, the various value using of the certain formula. Okay, okay, let's start with the data table with one input, and then later you will learn data table with two input. Okay. So let's use the same formula that we used a while ago. F equal to P1 plus K exponent N, right? Okay. So you make exactly like this in the can you make it? So let's find the future value of your money. So you have present value P, you have interest rate K, and the year of saving N. So the one in yellow is the one that you input. Okay. And then you calculate the future value F using P1 plus K exponent N, or using your Excel formula, that's fine. Okay. And then after you make this, okay, in column D, you start to make like this. You just type this one. Okay, so in column D, you type 10%, which is just equal to K, and then the F. Okay, after that, you type in column D, you type this. For example, from 9% and then plus 0.01 until how many percent that you want is up to you. So you create a table of K, different K. Okay. After that, you highlight. Okay, you highlight everything there, something like this. And then you go to Excel, okay, in what if analysis, data table. Okay. And then what you will do, because your data table is in the column, so you will put input cell, okay, which is P3, in this case K, right? So P3, so and then you click OK. Then what you will get is the whole F for each K. Awesome. Okay, try it. Okay. Of course, after you do that, you can start to plot. Yeah? You can start to plot. Okay. Paper, so let me make. So I make a new sheet. P.
Sorry, sir, you aren't sharing your screen.
Yeah, okay. So I make a new sheet. I will put P, K, and then I calculate the F, right? So P, you can put any number. So where is 1,000, 10, and 5. Okay, let me put that. 1,000, 10%, and 5. Okay. And then this one is what? Your P multiplied by 1 plus K, right? And then exponent of this 5. Right? So this 3 is the yellow, meaning that this is the input. And this is the output, so I put a different color. So now I want to make data table. So this is K and this is F. So in the beginning, you put that K. You just equal. And then here, you put that F. Right? And then after that, you make the real table. It's up to you. For example, I start from 9%, from 0.9. Okay. And then this one plus 0.01. Right? So, and then you highlight. And then what you will do, you go to, where is the table? Table. Oh, there. What in data, what is analysis, data table. Right? And then the column input, where is the column input? The column input K, right? K is this one. Okay. P2 in this case. So click OK. Then I got it. Okay. After that, I can plot. Okay. There. Okay, this is the plot between K and F. I stop sharing. How about you? Can you make it? So you have a formula and you have one input, and then you want to make variation of that input value, right? You want to make a variation of that input value toward one output. So the output here is F, the input is K, right? You select the table and then you go to the data, what if analysis data table.
Data table. Row input cell, we select the K, right?
Column, yeah. Column, yeah. Because you want to do it in column, right?
Oh, yeah.
And then you select what is in that column. The input is the K, right?
Oh. Oh, sir. I will share my screen. It doesn't work. Do I select this one?
No, you already make it work. Why it doesn't work? One.
Oh, I didn't. Oh, this one I select. I do it normally. Oh, we don't do this normally.
No, you don't do that normally. Only the beginning.
Yeah. Okay. So data table.
Okay, and then no, you
This
go okay, not that one.
Oh,
No,
this one.
oh, no. K is in B2.
Oh, this one. Oh,
Yes, yes, and then click OK. No, you select first. You did not select.
I already selected.
No, no. What I mean is you need to select D3
Oh,
till E30.
yes. Okay.
E30 until E30.
E30.
Yes. Yeah, okay. And then you put that.
Oh,
Wait. Before the data table, you select first. So cancel.
so we select this.
Yes. And then you go to data, data table, and then column, you go to B2.
B.
Click OK. There.
Oh.
Oh, what happened? Oh, let me check F. Your F, what? How do you get your F? Oh, that's why.
Oh, this one should be this.
No, that one should be equal of B4.
BE4.
B4.
E.
B4.
Oh, hold on. E4. The rate.
B4. Which is your F. No. Equal B4.
Oh, okay, wait.
Don't put any formula. Don't put any formula there.
Equal B4.
Yes. You remove the formula first.
Yes, this one.
No. Let me share my screen so that you will see.
Oh, wait. Yes. Okay.
Okay. In here, I just put B4.
Oh, equal V. Oh, without the V.
Without anything.
FV. Okay.
Here also, this one is equal B2. Without the,
Yes. Okay. Yeah.
okay?
Oh, yeah. Okay.
Okay. So, does it work?
Wait. Let me.
You want to share again?
So okay, I will wait. I'll do this one first.
That one is equal.
Yes, equal.
No. Equal
Yeah.
of
This one.
B2. Yes. And then that one is equal to B4.
Equal to B4.
Yes.
And then we don't do anything right here, right?
Yeah, that table you need to delete again because that is
This
already.
one should. Okay. Select this. If
No.
table.
Okay.
Column input cell.
B2, yeah.
B2.
Yes. Click OK.
Oh, wow. Okay.
You got it. Okay. There you got it.
Yeah. Okay. Thank you, sir. Yes.
Yeah. Very nice. Right.
Yes. Very quick. Yeah.
Very quick. And this is very nice because now you can change.
Oh yeah. When we change something, it changes all of them. Okay.
Yes. Very nice because now you can vary your value without actually doing it.
Yeah.
Okay.
Oh.
Livy, can you make it? You want to share your screen? This class is nice because only 3 students, so very special.
So this one, but why the table look like
Oh, you
this?
make it, yeah.
Yeah.
Why though?
Wow.
It's very. Can I see? Can you go to what is it? E3?
E3.
E3. Oh, cell. Can you click cell E3? Oh, okay, good, very good. And then E4. Okay, very good. Okay, super.
But the graph is like
The
this.
graph is a little bit strange, but will be a little bit up. Yeah, but this okay. Maybe because you put it in percent, that's why.
Oh, okay. So,
Yeah, it's just formatting problem. That's fine.
so if I change this, the result, the
Yeah, you can change the format of column D numbers.
so
So you select down and then change that to numbers, for example.
I need to delete this first.
Okay, if you want.
Okay, so,
Then okay, okay.
and this, the insert,
Scatter. Yeah, correct. And scatter plot
it's the same, sir.
is the same. Okay.
Yeah.
Okay. Until 14%. Oh, I think I know why. Because your number, your until 14%, right? Here,
Yeah.
yeah. So because you put 0.01. In my case, I put 0.1, so I get until 35%.
Oh, okay.
Okay.
But it's not already correct, right?
Yeah, it's already correct. It's just scaling problem. Okay, no problem. Very good. Okay. So let's continue with the second one. The second one is data table, but now you have two input. Okay, so I will share my screen. Okay, this is what you make a while ago. So now we have two input. Okay, so now you want to get the table of F, the same as a while ago. Okay, the difference is now you need to put also K and M. K is the first input, okay, M is the second input. Yeah. So what you will do, you will put F, okay, in that column, in that cell, and then you create a table of K and then a column of K, and then you put a row of M. N is 1, 2, 3 until it's up to you. And then you highlight everything, say up to 5, for example, here. Okay, you highlight everything and then go to a data table. Okay, then the input cell, okay, the row input cell is what? Okay, the row input cell is the P4, in here is the N, right? And then the column input cell is P3, which is the K. Okay? And then you click OK, then you can get that table. So this is the table between between N and K for the future value. Can you make it? Okay, it's the same as before. So I copy this. Okay, I'll share my screen. Okay, I copy this and then I will, okay, and then I create a new sheet. Put here. Right. Then I will put the K. Okay, let's make the table here. So this is the equal to F. Okay. And this is the K. Okay, and this is the N. Okay. So say I want to put this one plus 0.1. This one I want to put from 1 to 1 until 6. And then I will copy this until here. Oh, this is too much. And then what you will do, you will highlight, okay, and then data, right? Data table. The row input is the N. The column input is the K. And then click OK. Yeah. So you're supposed to get at N equal 5. This is exactly the same as that one. Right? So to check whether this is correct or not. So you can do. It works. Very good.
Yes. So yeah, this.
Wow.
Like I just
So, yes.
this.
Yeah. So the input is N, okay, that's it.
Okay.
And then okay, you get everything, yeah. And then to check this one is the one that you put there, 0.1 and 1. Where is that? 0.1 and 1 is 1,1,1,0,0, yeah.
Hmm.
So you get that. Very good.
Okay, so
So this is the future value of various N and K. Of course, in reality, you will have a much complicated formula, okay? And then now you want to know what is the relationship between this formula and that input, the two input, and you can start to create table, right? Okay, so this is very useful. So Livy, you can make it. Yes.
Yes. Wait. Not finish yet, sir.
Okay. You want to share your screen?
Okay. Oh, this is one. Yes.
Yes, you make it. Eh? So, oh, why replace something else?
It should be.
Okay.
Yeah.
So 1,650 with this at 10%. Oh yeah, okay, fine. Correct. Very good. Very good. So you know already the data table financial. Okay. So now let's do some inverse function. Okay, let's do this. I will share my screen. I create a new sheet, okay? Oh, okay, in here now. Yeah. It's the same sheet that a while ago, okay? So I want to get F. Okay, this is my target, okay? Target F is exactly 5,000. Okay, so what is my P? If I want to get my F is exactly 5,000, what will be my P? Can you, this is an inverse, right? Meaning that you know the output, you want to know the input. Can you do it? Of course you can do trial error, right? Okay, the K and N does not change, okay? All you need to change is only P. Question is, I want to get a certain value of my F, the output, right? The input is P. Now you have three input, right? P, N, and K, but K and K does not change. I want just to change P. Okay. How I will get the P that make F exactly 5,000 or almost 5,000. What is the value of P? Think about it. Right? You want to control something, right? If you want to control your target, right? Say in your business, you said, I have this target this month. So how much is the input that we need to put? And then you said, I don't know. You have Excel. Can you do it? When then you start to do trial error, isn't it? So what you will do? So I will do a trial error here, okay? So let me do a worst case first, okay? So I will do this as trial error. So I will just put here equal to this one. Okay, the input is P, right? So I will just equal to this one. And what I will do, I will put, say, if I put 1,000, okay, and then I will say, if this F is equal to this one, target F, then okay, right? Otherwise, not okay, right? This is the one that is, oh, not okay. Maybe if I put 2,000, what will happen? Oh, still, this is 3,000 now. Not okay. How about if I put 3,000? Oh, almost, okay. How about if I put 4,000? Too much. Then you will say 3,500. Oh, still too much. Then you said 3,300. Right? This is what you will do, right? You do trial error to reach your target. My question is there any better way to do that? You can do trial error, isn't it? Okay. Then you say, okay, I will do trial error. So is there any better way to do that?
Oh, we can use Coolseek, the one that's
Yes.
next to the data table.
Correct. Okay. Okay, so you can use Corsic. Okay, so Corsic is to do exactly that purpose. Okay, so I will share my screen again. So you use Corsic, right? Where is the Corsic? There, the Corsic, yeah. what do you want to set? Of course, this is what you want to set, okay? Right? To value what? To value 5,000, right? Which cell you want to change? The P. Okay? Then click OK. Oh, there you got it. Okay. The goal, the target F is exactly reached when P is equal to 3104.607. Okay. Then this is okay already. Can you do it?
Yes.
Very easy.
Wait, I share my screen.
Mm,
So this I set the F
okay.
feature value and then
Mhm.
normal one like the
Okay.
N, the K, the N, and also
Yes.
the P. Normally, like in the beginning, I just put it null, and then what if goal sig, select this one, set
5,000.
5,000 by changing cell this,
Yes. And click OK.
and then it will find it for you.
Yes, it will find for you. Okay. Exactly 5,000.
Mhm.
Good, right?
Okay.
So there's a program which search for you. Nice.
Yes.
Yes. So it's very useful. Goal seek is basically, you understand, you have the goal, which is your target, and you have one input. Okay? You have the goal, and you have one input. And you have one output, you have one input. Okay?
Mm.
And then you start to search. Okay? So, Livy, how's it? The table finish. Save.
Wait, I'm still trying.
Okay, you try. Okay. So punch, open the goal seek slide.
Yeah, I will open the goal sig slide.
Sir, what should we do
Okay, you share your screen. So that
by changing cell?
Livy, you can share your screen.
Oh, wait, let me cancel this. Okay. This one. Wait, let me.
Okay, so you have this P. Where is your formula? Wait. Before that. Okay, let's make it again, Livy. Let's make it again.
Okay.
Put yellow in P. Where is your formula of F? Can you show me the formula of F?
This one.
Okay. So let's do it here. Okay. Yeah.
Okay.
The one that you input, can you put it as yellow so that you know this is your input? Where is your input? The input is the numbers. It's not the formula. So the input is actually B2, B3, B4. Is that correct?
Yeah.
Put it as yellow. Oh, very good. So now you want to put your PFV to be 5,000. So you go to data in the menu data. What if analysis goes and then set the value is P6. Okay, two value is 5,000. By changing cell is B2. And then click OK. Wow, you got it. Just click OK. Right? Okay, easy?
Yes.
Yes. So let's go to the next lesson, which is Colsic in Google Classroom. Where is my Zoom? Share screen. Colsic. Okay, so say you have trouble with the story problem in, say, high school algebra. Question is, can you make Excel to solve the problem? And then we can make it a little bit more complex, okay, problem that you want to solve. For example, the root of polynomial equation, solving inequality equation. Actually, if I want, you can also calculate eigenvalue of a matrix if you want. But anyway, so Excel have ability to do inverse, okay? So data, what is analysis Colsic. So it's very simple, right, to solve equation of single unknown variable. Okay, if you have several unknown variable you want to solve simultaneously, then you use MS solver later on. After midterm, we will discuss solver. Okay. So okay, can you solve this problem? So Maria and Edmund have a lover quarrel, okay, while honeymooning in Seattle. Maria stormed into her Mazda Fiesta and drive 64 miles per hour toward her mother home in Los Angeles. So the 2 hours after Maria leave, Edmund jumped into his BMW in hot pursuit, driving 80 miles per hour. How many miles will each person have traveled when Edmund cuts Maria? So this is again, this is high school algebra. Can you solve it? I think you solve this when you enter your university, isn't it? In the test. Yeah, to solve that, what you need to do. Okay, so first you set up, okay, Maria's speed. Okay, and then Edmund stop time. Yeah, Edmund speed, you know, right? And then the time of Maria drive, say put 0 per hour, and then you put Maria distance and Edmund drive, the time Edmund drive, and then Edmund distance, and then the distance difference. Okay. Of course, your goal is to create so that the distance difference become 0, okay, by changing the time of Maria's drive. Okay. And we know that the speed is distance divided by time, right? So putting everything, then you get the value of 10 hours.
Oh, is it 10 hours, sir? Not 8. Oh, the distance. Oh, yeah. If the time is Maria's time is 10 hours, yes. Yes, Maria's times is 10 hours, but Edmund's times is 8. Yeah, I got 8. Yeah, I count the Edmund's time. Yeah.
Right.
So they traveled 660 for 640 miles.
Okay, they travel very long time.
Yeah, that's really far.
That's almost Jakarta Surabaya already.
Yeah.
Anyway, it's just a drama. Love quarrel.
So we do it with Kulsi.
Yeah, you can do it with code seeking.
Okay.
Of course, you can solve it using algebra, but it's more fun using Excel, isn't it? So using COSIC, you just put the value and then you get the result. Hmm?
My wait. C9.
You want to share your screen, Pancha?
Oh, so we goal seek the distance difference. Oh, yeah.
The difference
Okay. So I will just.
to make it 0, right?
Yeah. So M is Maria and E is Edmund, right? So
Hmm.
difference is this minus this. But this one is, yeah, okay. And yeah, we wanted to cosec this one 0 by changing the time. 10. Yes. Okay.
Okay. The same.
Yes.
Yes. Very good.
Yes.
Right. So Levi, can you make it? Yes. Yes. So of course you can also do different things. Okay. So say you have a cubic polynomial. Okay, now I'm sharing the mathematics here. Okay. How do you find the root of real root of cubic polynomial? Something like this. In Excel, how do you solve this? Yeah, you need to use COSIC, but how do you do that? Is there any idea? When you look at the equation here, okay? So x cubic minus 2x squared plus 6x minus 3 equals 0. Then find the x that make it 0. What to do? So, yeah. First, you put the coefficient. Okay. The coefficient is what? 1 minus 2, 6, and minus 3. Okay. So 1 minus 2, 6, and minus 3, right? And then you put the equation here in column G4. Put the equation there. Okay. And then you guess the initial value, the x. Okay. So in here, the B6 is the x that you guess. Okay. And then, of course, after that, very easy, right? all you need to do is just to do a call seek. Okay, so set the cash value, set the Y value to 0 by changing what? The cash of X. Okay. So, can you try? Oh, tell me, when is your midterm?
Let me check, sir, for our spreadsheet.
It's on Monday, sir.
Monday,
Yeah, Monday,
what date?
For
October 4th.
Yeah,
October 4,
at 9.
900. Okay. Yeah, in Google Classroom, okay?
Okay, sir. Yes.
Multiple choice. Very easy. But of course, you open your Excel to say example like this. Okay. Say, I give you polynomial equation, and then you need to solve X. And be careful, okay? So in here, you solve only one, right? But actually, cubic equation have 3 values. Okay, so if you only answer one, and actually there are 3 values, so if you don't answer all of that correct answer, then you fail that question. Okay. Meaning you need to answer all the possible correct answer. Unlike in Moodle, Google Classroom does not allow a partial answer. So you will not get 1/3 or 1/5.
What do you mean partial answer, sir?
In Moodle last semester, if you have 4 choices and then the correct answer is two of the choices, if you solve one, then you get 50%, right?
Oh, okay.
Okay, but in Google Classroom does not allow that. So I'm sorry. You make a mistake. For example, the answer is 2, but you answer only 1, you get 0, not get 50%.
Yeah, okay. Why aren't we using your Moodle again, sir? Like last year, is it?
No problem if you want to use Moodle.
Yeah, it's fine. Petra also has this Moodle called cloud.lentra.petra.ac.
Yes, but I don't know how they will give to me or not. But because last semester they give, but this semester they don't. So I don't know why they don't.
Oh, it's probably because last semester we used Lentera, the normal one, where the server with the server from Petra, right? But this year they actually moved the server to the cloud, so they created a new one.
Yes, I know. But when I check the cloud Lentera, I also don't have any of my subjects there.
Yeah, okay.
So then I cannot even create that subject. So I don't know.
Yeah, I don't know. Okay.
It's so strange.
Only one of our classes actually use Cloud Lentera. Everyone else uses Google Classroom actually.
I see. So if they provide, so I will use, but they don't provide, so I don't know how
Yeah.
that and so on. Anyway,
Sir, for the y, what is the equation?
this one,
Oh, so before. Oh, yeah, okay.
the equation is there in the slide.
Okay.
Sir, can I share my screen?
Yes, you can share your screen, please.
Why is not the same as the result?
Not 0. Oh, you did not do a COSIC yet. Oh, not the same.
Wait.
1 minus 2, 3 and minus 3. Is that correct? Yes.
Yes. 1 minus 2.
So F4 times F6. No. I think you made mistake. That the x that is exponent 3, not the coefficient.
Wait. The x. Oh, so this should
It is the
be
F4 that you exponent 3. F4, F6, oh, correct. F6, it's 4. What is H4 exponent F6?
this one.
That is multiply, not exponent.
Oh, yeah. Okay.
Okay, that's correct.
Okay.
Okay, that's good. Okay, very good. Okay, now you do COSIC.
And then we go seek this.
Yes, by setting the x.
Wait, so it's the data, seek, and then this one, right?
Mm-mm.
To value 0. This one.
Okay, very good. Yes, you got one. The problem with COSIC is you can only serve for one.
Oh,
So this is one of the answer. Is that the same as my answer?
wait.
It's the same, right? So what happened if you start from 10 instead of 0?
Start with
What happened if your guess of x is actually start from 10, not from 0? COSIC again. Will you get the same answer? The cubic polynomial have 3 answers. Right? So cubic polynomial have 3 answers. So if you start from 10 instead of from 0, and then you do COSIC again.
Oh, wait, sir, you're not
Yes.
sharing.
Oh, okay. I will share. Is this one? Okay. So I start from 10 here. The result is I start from 10, right? So is this the same here? So what I will do COSIC. Set this cell to 0 by changing this result, right? Oh, still the same. What will happen if you do instead of 10, now you put minus 10? will you get the same result? So I will set the y to 0 by changing this value. Or still the same result. Yeah. So the question is, how can I get the other result? Supposed to have a 3, right? 3 answer. So the idea is goal-seek will start from initial value, okay, and then go to the nearest value. If you can guess the initial value, okay, then you can get that result. If you guess differently, you will get different result. So initial value matter. Okay, the same later with solver. Okay, so initial value matter because it will go to the nearest. Okay. Okay, so I think we extended our time. Sorry for that. Yeah. So,
so it's not actually like exactly 0, but just very close.
it's a numerical. Okay, so it will not become exact 0. So, but it's very close to 0. It's fine, right?
Okay. It's very, very small.
Yeah, yeah. So, okay, let's continue next time for this goal-seek. Question before that. Did you learn about linear algebra?
Yes, we are having classes on linear algebra on this semester. Yes.
Okay, so did you learn about eigenvalue? No.
Sorry, sir. Which one?
Eigenvalue.
I think not.
E, like
Eigen.
not really. I don't think so. Not yet. Maybe.
Eigenvalue. No, not yet, right? So if not yet, I will not give. So if you have learned, then I will put that as part of the goal-seek. Because you can also use in matrix, you can sort the eigenvalue of matrix using goal-seek. There is no point to give you that if you don't understand Gil. I don't want to explain the whole concept of eigenvalue, and that's very long. That's fine. Okay, thank you very much for today. So do your online exam in midterm, and then see you again the week after midterm.
So we are going to use Google Classroom or your model.
Which one you want?
I think your model.
You want model? Okay. Okay. Make a model. Okay, I will make a Moodle class for this.
Yes, sir. Yes.
Yeah.
Because of the grading.
Yeah.
Okay, I will create. It's a special Moodle. Okay, I will put in Moodle. The reason I start to make a Google Classroom, I want to try, and then I will. The other class have many students, so if I Moodle, I need to email one by one. That's it.
Yeah.
But anyway, your class is only 3, that's no problem. Okay, so I will make it Moodle. Thank you.
Thank you, sir.
Okay. Thank you, sir. See you on Monday.
See you on Monday.
Yeah, next week for the midterm.
Midterm, I will not come, so you just join the Moodle.
Oh yeah. Oh, so we just join the. Oh yeah. Okay. So we just do it on Moodle. Okay. So.
Yes, you just join the Moodle, and then if you have a problem with the Moodle or with the exam, you tell me. Okay.
Okay.
Okay, sir. Yes.
9 o'clock, right?
Yes.
Yes, 9.
I'll make it 9 o'clock. Thank you.
Okay, sir. Thank you.
Joy,
Thank you.
then the exam is in Moodle.
Yeah.
Sorry.
Please tell Joy. Joy did
Oh
not.
yes. Okay.
Okay.
Yes.
Thank you.
Okay. Thank you, sir.
Sir.
Bye bye.